So in this video we are looking at error propagation. So if you let x represent some measured value of a variable and then let x plus delta x represent the exact value, then delta x is the error in your measurement, right? So when you see things like plus or minus 3 minutes or plus or minus 20 feet, things like that, that is the error in measurement, okay? That's the delta x here. So if the measured value x is used to compute another value for f of x, then the difference between f of x plus delta x and f of x is the propagated error, okay? So we find that, we put that exact value in minus the measured value gives us the actual propagated error. So if we look at this, that propagated error, delta y, but we know that delta y can be approximated with dy, right? So check this. If we want to find dy, then we're going to take the first derivative at x and multiply it by the measurement error, okay? So you take the derivative, evaluate it at the value of x, that measured value, and then multiply by the error value, okay? So for instance, we have a small little ball, a ball bearing, and it's measured at 0.7 inch, and as we can see here, the radius is 0.7 inches, and that measurement is correct to within 0.01 inches. So 0.01 is our delta x, right? Now, we want to estimate the propagated error. Now remember, propagated error is delta y, but we're going to approximate it with dy. So we're just going to do the derivative times dx. So, derivative dx, right? Because that's what dy is. Well, in this case, we're talking about the error in volume. So we're really talking about dv, right? So we're going to go ahead and take the derivative, and we say that dv equals 3 out front. They cancel. We'll have 4 pi r squared dr. Not because this is with respect to the radius r. Well, I'm given that 0.01 is that delta x, but really it's dr here, right? We're going to call it dr instead of dx. So we're going to have, what would I say, it was 0.01. 0.01 is our dr. And in this case, we were given that r was 0.7. So we've got 4 pi times 0.7 squared times 0.01. So this is going to give us, let me get my calculator, 0.7 squared times 0.01 times 4 equals, and say 0.0196 pi, which if I multiply that times pi, you get roughly 0.061575. Okay? So that tells us that propagated error. Now, let's see. If I want to find relative error, okay? So relative error can be given by the ratio of the derivative to the original value. So we're talking about, in this case, dv to v. So if we know that dv was 4 pi r squared. If we take that and divide by the actual value of v, which is 4/3 pi r cubed, then we can simplify this down to this nice little 3dr over r. We can multiply our values or put our value for dr and r in, and we wind up with this nice little relative error. So anytime that you see somebody looking for a relative error, we're going to basically you're dividing the actual value by, or the, not the actual value, sorry, the measured value by the actual value. Okay? So measured divided by actual gives you like the error percentage, basically. So if you have any questions about this, just shoot me a reminder or ask a question in class.